Okay, so we're looking at a video on applications of log functions, and most of these will be log to base 10. Okay, so don't be too fussed about log any other bases. And any questions, again, this video is applying to a 12 methods course in 2017, and so the questions are already loaded on Moodle, and in assessment we'll just be looking at the same sort of questions. So we're looking at some applications. We're going to be looking at pH levels. We're going to be looking at magnitude of earthquakes and also sound. Okay, they're the ones we're going to be looking at, so magnitudes of earthquakes. So the first one, again, you'll have either be given these formulas or you'll have them on a cheat sheet. So the first one we're looking at is pH level. So for instance, here's an example. For pure water, the concentration of hydrogen ions is 10 to the minus 7. Find the pH of water. Now we know the pH of water is going to be 7, but this is how we do it. So we use the formula. There's a minus sign in front. So we've got minus. So we put that number for the hydrogen ions. So we end up with minus log 10 to the minus 7, and log and 10. These are the same base. So we end up with minus a minus 7, which is where the plus 7 comes from. Okay. In the next one, we've got the pH levels, and we need to find the concentration, so we're going to use the formula backwards. So we've got 12.5 equals minus, so we get rid of the minus sign first by putting the minus across. And then this is log to base 10, so the base is 10, so 10, that's the power, so 10 to the power equals the answer, and so we end up with 10 to the power 1 times 10 to the minus 12.5, and that's the concentration of hydrogen ions. Okay, so just remember the answers to logs are indices, so that is the indice, so that's why the indice on top of the base 10. Copy and come across when you're ready. Okay, so in this next one we're looking at the decibel scale, and like here they've written in that it's log to base 10, but we don't have to. If we leave the 10 out, we don't have to actually indicate the 10 there. So here's the formula for the number of decibels. It's a formula to do with a ratio of the sound that we've got been given and this basic reference level, which is the faintest sound. So this number down the bottom will always be the 10 to the minus 12. Okay, and then we put the intensity of what we're trying to measure on top, and then we take logs. So this formula either will be given to you or you'll have it on your cheat sheet. Okay, so we've got a jet engine in the information up here. So that said the jet engine is 10 to the 3, and so we've got 10 to the 3 over 10 to the minus 12, and then when you use your indice laws you get 10 to the power 15, and then that indice out the front using the indice laws that 15 comes out the front, so we end up with 150 log 10, and log 10 equals 1, so we end up with 150 decibels. So a jet engine is said to have a loudness of 150 decibels. Okay, so this next question in example 5.14, compare the relative intensities of a sound that is 80 times larger than the basic one. So what we've got is we've got a sound that is 80 times the basic level, so we put 80 times the intensity on top of the intensities, and then these two numbers cancel out, and then on your calculator we get log of 80 and we get 1.9, because if it was 2 that would be 100, so log of 100 is 2, so log of 80 is 1.9, and then 10 times 1.9 is 19, so we have a 19 decibels, so the relative intensity is 19 decibels. Okay, copy that and come across. So here you've got two more examples to do with the decibel formula. So how many times more intense is a sound of 50 decibels? So this time the decibels, this is the decibel, so that goes out the front of the formula. Then we divide by 10 to get 5, and then this is the answer as an indice. So we take 10 to the 5. So the intensity, this number here, intensity over the threshold is 10 to the 5, and 10 to the 5 is 100,000. So the sound is 100,000 times louder than the threshold if it was a 50 decibel. Okay. now this last example here with the decibels is comparing a chainsaw with 115 and a cat of 25. Okay, so we're putting the 115 out the front or the 25 out the front. So the first thing you do is divide by 10, and then it'll be 10 to the power of 11.5 for this answer, and divide by 10 gives us 2.5, so it's 10 to the power of 2.5. And so the relative intensity will be 10 to the 11.5 on top, divided by 10 to the 2.5 underneath, and the iOs just cancel out. And so when you use your indice laws, you subtract the power, so you get 10 to the 9. And so 10 to the 9 is 1 billion times. Okay, so 1 with 9 zeros is 1 billion times difference. So a chainsaw is 1 billion times louder than a purring cat. Okay, and that sort of makes sense. Okay, copy that and come across. Okay, the last formula we're going to be looking at is earthquake intensities, and it's pretty current actually. We've had lots of earthquakes in Mexico. I think the last one in Mexico in 2017, just a few weeks ago, was a 7.1. So 7.1 falls into this earthquake that's major. So again, the formula we're going to have two formulas we're going to be using. One is getting the magnitude of earthquakes given the amplitude. In this other one, this other formula, which is also coming from Richter and another guy, is how much energy comes out. Okay, so again, these formulas will be given to you, or you'll have them on a cheat sheet, and we just have to apply them. Okay, so we're going to come across to the last page and have a look at how we use them. Okay, so how much more intense is an earthquake of 6 to 3.5? So it doesn't sound like it's very much different. So basically, the short way of doing it is you just find the difference between those two numbers, which is 2.5, and then you just raise 10 to that power, and on your calculator, 10 to the power of 2.5 equals 316. So it's 316 times greater. Okay, that's the thing with this log scale. You get these grading multipliers. So even with an earthquake that's 10 to the 6 and one is 10 to the 8, the difference is 2. And so it's 100 times more powerful between 10 to the 6 and 10 to the 8. Okay, so the short way to do it is you just subtract. So you can go through these steps here, or you can go straight to the relative intensities between the two is the difference between the numbers raised to the power of 10. Okay, and then what we do with the last part is to get how much energy. So there's an earthquake in 1989 that was 8.2, which is very, very, very big. Okay, so we use the formula. So we're trying to find the energy that's expended from a magnitude 8.2. So we put the 8.2 in that position there, and we get 17.1. And so this 17.1 is the answer as an index to the base of 10. So it's 10 to the 17.1, which is, okay, so basically we've got 10 to the 17 and 10 to the 0.1, and 10 to the 0.1 is this 1.26 out the front. So we've got 1.26 by 10 to the 17 joules, which is a huge amount of energy. Okay, so there's a worksheet on Moodle that for you to practice. Thanks, bye.